Hello everyone, this is Jeff from the Ozark Mountains in Missouri, USA. In part 1 of this series, we looked at building DurexForth for the Commodore 64, and we touched a little bit on how Forth works. Today, in part 2, we're back using DurexForth on the Commodore 64, and we're going to develop a nifty little program that I've used over the years to learn new systems and new programming languages. I found that coding this simple little program on Forth was a worthwhile exercise. I learned a little bit about input, output, math, conditional branches, and so forth. I thought that maybe since this program was such a good learning tool for me, it might be for others as well. We'll go step by step and look at developing each part of the program and testing it, and there's even a bit of troubleshooting and debugging along the way. While I've coded this same program many times over the years, in order to better communicate the idea for you, I whipped up this outline of the plan of attack. Let's take a look. The general idea is that we'll generate a random number that is in the range that we want, and we have to let our user input a number. We'll have a simple user interface that clears the page, prompts the user, provides feedback. It lets our user input a number, and it converts that from a string to a number and takes into account the user might enter something other than a numeral. We have to test that input to see if it's too high or too low, or if it's just right. So maybe we'll call that the Goldilocks function. And we'll provide feedback to the user about if they were correct or incorrect, and we'll loop back to do it again, or we'll jump to done if they guessed right. In order to have our user guess a random number, we first have to generate that. And we want to generate a random number that's in a range that we specify. And luckily, Leo Brody, in his fantastic book Starting Forth, included a nice little random number generator for us. And generating random numbers is a complex subject, and there's a lot of different thoughts on the subject. There's a lot of different qualities of random number generators. This one is simple, but it's surprisingly good. And I want to say thanks to the folks on the Forth group on Facebook for helping me understand how this little gem works. The first thing we do is create a variable called R&D, which you can think of as short for random. And then we have the word here. Here returns the address of the next entry in the dictionary, and that's a good enough starting seed as any, and we save that seed to R&D. This line is all done at compile time, so it's only done once. Then we have our actual random word. Now, a random word takes no values off the stack, and it returns an unsigned single length number, which is 16 bits. We start out by fetching what's in our R&D variable. We multiply it by 31421, which is a slightly altered version of pi, and then we add 6927, which main significance is that it's the right length and it's an odd number. We duplicate that result and we save a copy of that to our seed value for use next time. And you can think of this as generating a number between 0 and 1, but we left out the decimal point. It's just in fixed point. And the real meat of the random number generator is this word called choose. Now it's kind of swamped here by this massive number of comments I left in here. I try to keep the comments less than 40 characters so when I copy it over to the C64 it doesn't run off the edge of the page. At any rate, choose takes one value called range, and that just sets the range of random numbers we want, and it returns one value, which is our random number. Choose first calls random, and then you see the word star. Star will multiply the range value that we passed in and the random value, and it returns a 32-bit result on the stack, which is a double length number, which it comprises of two 16-bit single length numbers. And then we see a swap here. Well, the swap is going to swap the upper and lower half of that 32-bit number. Now, why in the world would we want to do that? Well, you remember I said that the random word is sort of like generating a number between 0 and 1 in fixed point notation. Well, if you multiply some fractional number between 0 and 1 by our range, what we're left with is a number where the lower 16 bits are that fractional portion that we don't want, and the upper 16 bits is our random number in the range that we want. So by swapping those, we have the fractional part, the lower 16 bits, on top of the stack now, and we can drop it and get rid of it. And what we're left with on the stack, what we're returning, is our random number. And I've also made this simple little test word, and all it does is create a random value between 0 and 9. We pass in the range of 10, so what we get back is 0 through 9, because we start counting from 0. Oh, I just noticed that this is wrong. There should be a space there. So what we will do now is copy all of this. And in the C64 emulator running DurexForth, I'll type in VI to go into the editor, hit I for insert mode, then I'm going to right click on the mouse, which will enter all that code in for us. And you see, even though I have a overabundance of comments in there, they are all less than 40 characters, so it doesn't chop any of them off. Now, having all these comment lines isn't really detrimental unless we run out of buffer length in the editor here, because when this is compiled, it gets rid of all the comments anyhow. One other thing you might have noticed is the decimal word up here. That's just telling Forth that we want to run in decimal pose as opposed to hexadecimal or octal. So all the numbers it encounters, like our fixed numbers down here, will be treated as decimals. And you'll also notice that in our source code we had this backslash here, which got converted into pound signs. And that may seem a little odd, but as it happens in Vice, the backslash key is mapped to the pound key on the real C64, so it works out well. That's just one of the ways of leaving a comment. The other is the parentheses. So this all should work. So if we hit the tilde key to take it out of insert mode, you'll notice the little I disappeared down here, but you can still scroll up and down. And we hit F7 to compile. That seemed to work. And if I type test, we do get a random number, so we can try that several times. Okay. Now, one thing I should have done before trying to run this, in case I locked our virtual C64 up, is to save it. But we'll kind of do that after the fact now. And I am first going to go back into insert mode and comment, oops, wrong key there, comment out our test function because we don't need that anymore. And you always need a space after that. You might recall from the episode 1 that forth is space delimited. So between all the words like the colon and your comment word and things like that, you need a space. You don't actually need a space, but after or right here, just before the trailing parentheses or the closing parentheses, but I like to put it in there because it looks better. So now that we're ready to save this, we'll make sure that we are not in insert mode by hitting tilde, and then we'll hit colon W store, which is the exclamation point, and we'll give it a name, and we will call this random. Now we have that saved to our virtual floppy drive that DurexForth is on. And from here we can hit tilde again and get out of there. And now we're on ready to test our next bit of code. If you're programming in a language like BASIC, then numerical input is fairly basic. And if you're programming in something like machine code, it's a lot more difficult because you generally have to do everything yourself. Forth is somewhere in between those. Now, this numerical input is probably the most complicated part of this whole program, just because there's a few different things we need to stitch together. We first have to input a string, and then we have to validate that the user didn't enter anything other than numerals. Then we've got to convert that to an actual number, and then return that number on the stack. Now, we could have done this a few different ways. One of them is just look for key presses and ignore any key press that wasn't a number. That would be a fairly easy way to go. I wanted to learn a little more about string input and string manipulation, that type of thing, so I used a different method, and let's get into it and see how it works. So the code we need to let the user input a number is on this page. The first thing we do is switch to hexadecimal mode, because part of the code that is in the compatibility module here seems to be in hex, and if we don't do that, it doesn't import right. What we need out of the compat module here is this word, IntoNumber, which converts a string into a number, or it tries. It'll give up if it hits a non-numeric character. And then we switch back to decimal. One little thing I noticed with DurexForth is if I have this decimal right up under any require statement, it doesn't work right. It likes to have a carriage return there for some reason. After switching back to decimal mode, we create a variable called InBuffer, and then you see 20 a lot. What this does is give us 20 bytes that are assigned to our variable called InBuffer, so we've in effect created an array. Now, it should be noted that this line is only needed for testing, that the main program that is calling these input function would provide the buffer address itself. Then we go down to where we let the user input a string. Now, into this word we pass in, which is the maximum number of characters that we want to be able to input, and the address of the buffer. So basically this is buffer length and buffer address. The first thing we do down here is duplicate the address, which is going to be on top of the stack, and then we add 1 to it and rotate the position so that our number of characters is at the top of the stack. Now, when I first got into things like this, it was hard for me to visualize what was going on. And one thing I found very helpful was to go line by line like this. So I could put a stack comment after each line. So I would have in address, address. And then the 1 plus here would give me in address, then address plus 1. So basically I'm creating comments, stack comments that is, for each line to help me better understand what it's doing. And then when we get to the rotate down here, oops, technically there should be a space there. When we get to the rotate, that's going to bring the third stack item to the top, so it would wind up with address, address plus 1, and in. Like that. Accept is another built-in fourth word that accepts character input from the keyboard or perhaps some other source, depending on how you have it set up. Now, accept is going to consume the top 2 items on the stack, which in our case are going to be the number of characters to accept and the address to start putting those characters in, which in our case is our buffer address plus 1. Now we're skipping that first byte of our buffer because one of the string representations in Forth is called a counted string, where the first byte of the string is a count of the number of characters in the string and the rest are the characters of the string. So accept is going to take our number of characters and our buffer address, and it is going to return the number of characters that it actually accepted. So left on the stack we'll have our original buffer address and an unsigned integer, which is the number of characters that it accepted. And we come down to swap. So let's go ahead and see what that swap does for us. So now we will have our number of characters and the address of our buffer, like so. And then we have this C store. Now, the store, you might remember, saves a variable. The C store saves just a byte to a variable. Now, the interesting thing about a variable in Forth is that when you type in a variable name, what gets pushed onto the stack is the address of the variable. So in our case here, what we have on the stack is the address of our buffer. So this is going to take in the address of the buffer and store just the low byte out of this cell. This is actually a 16-bit value, but we're only going to save the lower 8 bits, which is the number of characters that were taken into the string. Now, this code like this, as messy as it looks with comments on each line, is perfectly valid Forth code, and we can go ahead and copy that over into DurexForth, and it will compile it just fine. Our next section of code is IntoNumber ? Which is a sort of wrapper around that word that we wanted to import from above from the compatibility module called IntoNumber. We pass on the stack kind of a blank space on the stack that'll hold a double length value, and we pass it the address of our buffer and the number of characters in the buffer that should be evaluated. And what it returns is a double length number of what it was able to convert, if anything, and a flag to tell us if any non-numerical characters were encountered. So the first thing we do is call the built-in, or the IntoNumber word that we pulled in from the compatibility module, and we're giving it the three things on the stack above. What IntoNumber returns is the value of the conversion it was able to do, if anything, the address of the last character it was able to convert, and the number of characters left over. And this number of characters left over gives us an important clue. So we say if, and what's the if switching on, or what's it looking at? It's going to look at the last thing on the stack, which is this number of characters left over that weren't converted into a number. So if there was anything left over, and this works because as far as if is concerned, anything other than 0 is true. It doesn't matter if it's positive or negative. If it's other than 0, it's true. So if we had characters left over, we're going to drop the address because we don't need it, and we're going to put a 0 on the stack as our flag. And so basically this is saying that I left a comment here that if this number is anything other than 0, then something that was not a number was entered. Else, we're going to go ahead and drop that address part and return a 1 on the stack. So what we'll have returned, we can look up here, is the number we were able to convert, if any, and a flag to tell us if the conversion was good or not good. So that's kind of the meat and potatoes of our numerical entry function. And the way we would use that, I've demonstrated here with this little test method, is first we make sure that we are in decimal mode, so our user can enter things in decimal. We prompt them to type in a number, and then we call the input string word. We provide the maximum number of characters to be input, the address of the buffer, and then call the input string. Now, one thing you might remember is that we actually allotted 20 bytes for our input buffer, but remember that first byte is our count, our string count, the number of characters in our string, so we can only allow 19 characters after that. Thus we have 19 characters in buffer address, and then we call our input string. So now in our buffer we have the string that our user input. The 0, here is just leaving enough space on the stack for a double length return value. Then we're passing the address of the end buffer. Count will return the number of characters in the end buffer, which is, you remember, we're in the first byte there. And then it calls our IntoNumber question mark, and then it simply dumps the stack. So we'll go ahead and copy that over into DurexForth and see how it works. Okay, I've already copied the code over into DurexForth running advice. Here's everything. Now I'm going to go out of insert mode by pressing the tilde key. And then we're going to go ahead and save it before trying to compile it. So we'll hit :W store, and we'll call this InputNum. And we've saved it. I'll hit tilde again. Now I'm going to hit F7 to compile this. And that sparkling you saw along the edge was just what it was doing as it was reading in the compatibility module and compiling everything. So now, if we type test, it's going to ask us to input a number. So 1, 2, 3, 4. And you'll notice we've got 3 different things displaying here that are on the stack. 1, 2, 3, 4, which we typed in, and a 0 and a 1. Well, the 1 is the flag that our IntoNumber question mark returned. And then we have this 0 and the number we typed in. Remember that the IntoNumber question mark returns a double length number, and when we just dump the stack like this, it displays everything as single length numbers. So it's showing it to us as 2 different single length numbers with the high byte here, or the high word, excuse me, and the low word here. Now, one helpful tip with forth is if you have several things on the stack that you want to get rid of, instead of typing dot, space, dot, space, dot, if you just type gibberish and hit enter, it's going to feed that back to you and say question mark, which means I don't know what that is. But if we look at the stack again, there's nothing there. If it doesn't understand what you typed in, it clears the stack. So you're not starting from gibberish, at least. One other little thing I'll do while I'm thinking about it is go back into the editor, go back into insert mode, and I will comment all of this out. Now I could just delete it, but I'm going to save it again with this test function in place just in case I want to make some changes and test it again later. Now to save this time, since we've already saved it with a name, I can just hit tilde to go out of insert mode and go :W, and it already knows the module name. Hit tilde again and we're all done. So far, we've built a random number generator that will return a random number in the range we ask for. We also have a word that will let us input a numerical value and tell us if the user entered a non-numerical character. Now, we need a user interface. We need to clear the screen, tell the user we are thinking of a number between 0 and 9, and ask them to enter a guess. Once they have entered a guess, we want to test to see if they guessed high, low, or if they were right on the mark. We need to give them a chance to guess again if they were incorrect and congratulate them if they got it right. It would also be nice to count the number of guesses they made. So, let's get started. Here is the code for the main part of our little GuestNumber program. Now, we're requiring the 2 modules that we just programmed in. Require is like include, but whereas the include word will reload the module even if it's already in memory, require doesn't. Require goes and says, hey, this word already exists, I'm not going to reload it. Then we make sure that we're in decimal mode. And here we're creating a variable called inBuffer and allotting it 20 bytes of space. This is going to be our input buffer where the user has space to type in their guess. And then we're creating a constant called max value, which just holds the maximum value of our random number, our range. I guess range is a better word there than maximum. So let's go ahead and change that to range. Because we'll get, the range will give us, like we discussed before, from 0 to the maximum value minus 1. And then we have a variable guess, which just keeps track of the number of guesses that the users made. Our helper function here, correct question mark, is called when we have our random number and the number that the user has guessed both on the stack. And then we do an over and to dupe. Now, the effect that's going to have on the stack, and we can go ahead and look at that here kind of like we did before, is we have our random number in the guess, and the over is going to bring a copy of this second item over in front of the first item. So we're going to have random number, guess, random number. And then we do a toDup, which is going to make a copy of both of these. So we're going to have guess and number again. And the reason we're doing this is because we'll potentially need to test if it's high or low, and we don't want to destroy our random number. So now this is what we have on the stack. The less than, you can think of that as being parked right in between these two top stack items. So this is going to say, is the guess less than the random number? And if it is, we print low, and we don't need the other two guesses here anymore. So we're going to drop those, push a 0 to the stack, which is our flag to say that the guess was incorrect. Now, if this was not too low, then we're going to test again. So we're doing an else. That will pull in this other pair here and say, is the guess higher than the random number? If that's true, we're going to tell the user they were high and push a 0 on the stack as well as our flag. The only thing that's left, if they weren't high or low, is correct. So we're going to say correct. We're going to push a -1 to the stack. So what we'll be left with on the stack at this point, if we get here, is the random number and a flag of -1, which anything except 0 is true, so that is true. We have the thens to close out the if statements, and we also print a carriage return, and then we're all done. Now, when I was looking at this, this was my original version of correct question mark, and I noticed that I had this extra toDup in here that the extra toDup right here, which I didn't need. So I was duplicating the top two stack items again and then dropping them again, which I really didn't need to, because once it got to here and it tested that other pair, then I wasn't going to need them again for the else. If you had some other condition you were testing for, then you might need to do that. So before I forget, even though this is perfectly valid code here, I'll return the original appearance like so. Okay, and save it. The heart of our program is this word called GuestNum. We start out doing a little housekeeping by setting our guess variable to 0, and then we call the choose word with our maximum value, and then we use page to clear the screen. Then we get into a begin until loop, which has the feature that the main body is always executed at least once, and until the testing condition returns true. So we prompt the user to guess between 0 and the maximum value -1. This dot here prints out the maximum value -1. And then we call input string and provide it the address of the input buffer and the maximum number of characters that it can input. Once that returns, we set up space on the stack for a double number, and then we provide the address of the end buffer, the number of characters in the end buffer, and we call IntoNumber question mark. Now, IntoNumber question mark, if you remember, is going to return a flag where if it returns 0 false, that means that something other than a numerical character was entered. If that's the case, if what it returns is 0, then we're going to print out not a number. We're going to push a 0 flag to the stack for our until loop. If what the user entered was a number, in other words, there's going to be something other than a 0 on the stack, so we have our else condition. we add 1 to the number of guesses, and we call correct question mark. And correct question mark, as you recall, is going to return a flag on the stack where 0 is false, the user didn't guess correct, and 1 is true. And this then just closes out our if statement. And we have until. So until is going to evaluate the last item on the stack, which is either the 0 we pushed up here if the user entered a non-numerical character, or it's what the correct question mark word returned. So we keep looping back until the user guesses the right number, and once they do, then we're going to drop that last flag value off of the stack, and we'll print out the number of guesses that they made. Over to DurexForth. So I'm going to go VI we'll just call that GuestNum. And I did that a little different this time. When I called VI, I gave it the file name I wanted, and it flashed up there briefly, file not found. But that automatically sets the file name in the editor so we don't have to enter it the first time we save it. Now you notice my comments were wider than 40 characters, so DurexForth just chops those off, which is perfectly fine. Oh, good. Here's another little quirk moving between VS Code and Durex. You'll notice we have these superfluous question marks here. If you enter a tab in VS Code, Durex doesn't know what to make of that character, so you get question marks. So you have to watch out for that. And I thought I had got all that out of the source code, but I guess not. So we'll just clean that up real fast. Okay, that's okay. And that one. I think everything else is okay. Let's double check up here. All of that looks okay. Okay, so now we're going to save it, and the name's already in there, so I can just go tilde to get out of insert mode, :W, and it's saving GuestNum for us. Okay, hit tilde again. I'm going to hit F7 to compile, and this is going to bring in all the parts of the programs that we created, so it's going to take a little while to compile. And so I'll hit F7, and here it's flickering the border to let us know that it's thinking. And we'll just keep going in real time. Uh-oh. There is an error in something called set. Now the problem here is we don't know where this error was, but it's where there is something called set. So let's see if we can find it. I can do a Control F on this part and search for set. Okay, I got this set on the wrong side of that here, so this should have been like this. Oh, the dangers of overcoming. I don't know why that... Oh, it's highlighting it because I'm still in search mode up here. Anyhow, so we can go back over to DurexForth, type in VI again to go into the editor, and go into insert mode, get rid of that, tilde, :W, we'll save it again, tilde to get out of that, F7 to compile it again. Now it's probably already brought in random and IntoNum, so it shouldn't have to do that again since we used require and uninclude. I'll hit F7. Oh man, I'm really doing terrible here. Our 0 equals is down here. Oh, gosh. I thought I'd tested this out already, but I guess we'll get to do it in real time. Let's try it like that. Tilde, colon W. And I like saving after I make code changes like this because if you do something wrong, it's not too hard to lock up even a virtual Commodore 64. Tilde, F7. Oh, goodness gracious. The fun of debugging. Number of guesses. Oh, that's right here. Gosh. See, I was changing names in this to... and I didn't get it all changed on my source code after testing. Okay, so we'll go back into VI. And go into insert mode. But I guess you can see how to troubleshoot some of this as you go. Tilde, Control W to save, tilde, F7. There we go. Now theoretically this should work because it compiled. At this point we've corrected a couple minor syntax errors, so let's go ahead and test the program now. Gotta click on the right thing here. GuestNum. I will confess I've already done this and found a bug in the program, but it's a good opportunity to go through the interactive nature of Forth, and we'll find the solution again together. So I'm going to guess 5. It says I'm low. I'll guess 9. It says I'm low, which, you know, can't really be. The way I found to get out of this was to enter a 0. And it tells me I'm correct, which doesn't make any sense. If 9 was low, then 0 certainly couldn't be correct. And if we take a peek at the stack, you notice there's some things still left on there which there shouldn't be. So I'm going to type in some gibberish to clear the stack. And we'll start with a blank page. And we'll kind of go through what our GuestNum main loop does line by line and check the results. So the first thing it does is zero out the guess counter. So we're storing a 0 in guess. Okay, and then it generates a random number. So max val, choose, and this .s is just going to show us what's on the stack without destroying the stack. So it picked a 3 this time. Okay, and now it's going to get the input from the user. So we give it the maximum number of characters, the buffer address, and then call it input string. Now here's where we input our guess. I'm going to input 5. And then I'm going to take another peek at the stack and see what's there. Ah, why is there only a 3? Well, when we typed in our string, that was stored in the buffer, not on the stack right now. We have to convert that string into a number and push that number to the stack, which is what the next line does. So we make room for a double length number by typing in 2 single length numbers as zeros. We give it the address of the buffer, the number of characters in the buffer it should evaluate, and then we call into number question mark. Okay, and we'll take a peek at the stack again and see what's there. Now, what is all this stuff? Okay, well, the 3 is the random number it generated above. The 5 is our guess, but you remember that IntoNumber returns a double length number, which is the key here. So this 0 is the upper word of the double length number, which we're not worried about in this case because we're only generating small random numbers. And the 1 is the flag that's returned by IntoNumbers, and that tells us that a valid number was indeed entered. And if we go on down in the code over here, we have this 0 equals, so it's testing to see if that equals 0. And that's going to consume this first one right here, so we can say drop and take another peek at the stack to simulate what it's doing. And now we have our random number, our guess, and this extra 0, which is the upper word of that double length number. But you see, we drop down here to else because we entered a valid number. It increases the guess counter. Then it calls correct. Well, correct, let's look up here at correct. Correct is expecting a single length number. So what it sees is this 0. That's why we had to enter a 0 to get out of it. So there is where our error lies. Now, what do we do about it? Well, when we return from IntoNumber, remember we have the flag here that we need to do something with. And that's what we're switching on right here with this 0 equals. In the case of the user entering an incorrect character, then, we're going to need to get rid of this double length number. And in the case of the user entering valid numbers, we're going to need to get rid of this first one. So if we look at our code over here, if we go here and say to drop, we'll get rid of both the 0 and the 5, so we're only left with our random numbers, and we'll go back up so the user can take another guess. And when we get down here, before we check to see if it's correct, we'll need to drop that leading 0 because the correct helper function there is only expecting a single length number. So we get rid of that upper word because we don't need it. So let's get rid of everything on the stack with garbage. We'll go back into the editor like so. Hit I to go into insert mode. And so before we enter the 0 flag on there, we need to do a to drop. And then before calling correct, we need to do a single drop. So I will go out of insert mode with the tilde key, :W to save it, tilde to go back there, F7. Okay, let's go for broke and just run GuestNum again. Guess the number is 0 to 9. Let's try 5. Oh, 5 is high. Let's go with 2. 2 is low. I'm going to try 4. 4 is high. That only leaves 3. Hey, we got it right. Now, so we know we can guess the number and get it correct this time. So let's test out if the user enters an incorrect character. So we'll try GuestNum again. And guess 0 to 9, so let's say 5. That was high. And let's guess A now. Oh, that's not a number. Please guess again. So we know 5 is high, so let's try 3 this time. 3 is high. Let's try 2. 2 is correct. It took us 3 guesses. This is all looking good, but let's see if there's anything left on the stack that there shouldn't be. So we'll peek at the stack again with .s, and there's nothing there. So we haven't polluted our stack with unwanted things, and we have a working program. I hope that the run-through of this code was interesting. I know it can be a bit boring watching somebody else ramble on about a bit of code for a while, but this little program has always taught me a lot about different systems and programming languages over the years, so I hope it's of use to you as well. Looking back over the code, I see there's a few things I probably could have improved. For example, could have taken these 2 lines right here that do the numerical input and broken them out into their own word, and come up with just a simpler 1 line there that would have made a little more sense in the program and made that main loop a bit cleaner. Another thing that could have been done is to use the C64 Jiffy clock as the seed for the random number rather than using the here word. Of course, that would only work on the C64, but that's what we're programming on right now. I'm sure you can think of other ways to improve the code as well. Now, here are some more resources concerning Forth. There are a couple of Forth Facebook groups. One I linked to last time, but I just found out about another one for Forth on vintage computers. I'll put the links and the resources below. Also, in the last video I did on Forth, a gentleman named Peter Forth, how do you like that last name, was nice enough to send some, put in some links to some books, a lot of which were printed in the 80s. They're for more vintage machines, so keep in mind that some of the syntax and the ideas may be a little different for modern Forth implementations, but for using a vintage Forth on a vintage Forth computers, they'll be just the thing you need. Two of the documents in there I found really helpful was And So Forth by J.L. Bessemer and Adventures in the Fourth Dimension by Julian Noble. Now, somebody else mentioned, I think it was on the Forth Facebook groups, the book Threaded Interpretive Languages by R.G. Loliger. I'm about halfway through this book and I find it really interesting. It was also printed in the 80s, but it's more of a combination of reference book and tutorial on how to create threaded interpreted languages like Forth. So sometimes the descriptions can be a bit long-winded and kind of obscure the overall point a section's trying to make, sort of the can't see the forest for the trees type of thing, but stick with it and I think you'll find it is an interesting book. And also there are some links to sites to buy used books. I found this one on Amazon in nearly new condition, and there are a couple other places that you might find interesting, so those are in the links. Now, speaking of links and such things, please consider subscribing if you're not already a subscriber. It really helps me out. It's nice to see the number of subscribers grow, and having more subscribers means Facebook. Having more subscribers means that YouTube will suggest the channel more often to people with similar interest. And if you're subscribing, click on the little bell icon that's below. Oop, get my hand in front of my face. Click on that bell icon that's below, and it'll notify you automatically when I post a new video. Well, thanks for watching. I hope you found it enjoyable, and if you did, give me a oops, can you see me? Give me a thumbs up. Thanks. Bye.